Alright, today I'm going to show you how to revive that lithium-ion cordless 2 battery. I have here is a Ryobi 18-volt lithium-ion battery that is dead. And my previous video I showed you how to do it using the parallel mode, meaning you get another 18 or 20 volt battery and hook it up in parallel to raise the voltage of the dead battery, and then you put in the charger, and the charger will recognize the battery and charge the battery. So but that was different because the battery still got some voltage. This battery, on the other hand, is absolutely dead. It doesn't have any voltage at all. And let me show you what I mean. Absolutely dead. Zero. Nada. I'll show you my volt battery. Got 20 volts. This one, 0. And I actually try the parallel method. I hook up the positive to the positive and negative to the negative to the good battery, but it's still not taking a charge. The voltage remains 0 after like an hour. So today I'm going to show you a different way to revive this dead battery. And this dead battery here, it is brand new. I put it in a radio, this kind of radio, and it's got a USB port right here. And then even when it's not in use, it still uses power from the battery. And I turn the radio off and leave the battery in. Even though the radio is off, it still consumes power from the battery and draw all of the power out of this battery until it reaches 0 volts. So there's no way. I plug in the charger, it doesn't take a charge anymore. And I tried the parallel method, doesn't do anything. So today I'm going to show you how to do it in a different way, how to revive it in a different way. And first, let's disassemble this battery. There are only 5 screws, 1, 2, 3, 4, 5. I'm going to take it apart and show you the inside. Alright, so here's the inside of this battery. There are 5 18650 cells, and let's see what we got. One volt, 1 volt, 1 volt, 1.06 volts, 0.85 volts. So at least we got here almost 5 volts, and there is 0.02 volts here. I don't know what's going on between here and here, that we lose 5 volts. Probably this circuit board is a culprit. But what I'm gonna do next is I'm gonna charge each individual battery to its full voltage, which is 4.2 volts, and that should revive this pack. Also, this battery is controlled by this circuit board, and if this circuit board is bad, even though I can individually charge each cell here to 4.2 volts, if this circuit board is bad, then this battery is also bad. So it will depend a lot on luck too. So you have to wish that this circuit board is still good. If there's a fuse somewhere here that is blown, you're in bad luck. So just hope for the best. But the best thing I can do right now is just charge this up and see if that works first. If all of these are charged and we still don't have any voltage here, then this circuit board is dead. Look at how complicated that is. A lot of times the battery pack is totally fine, but the circuit board is bad. Doesn't have to be the whole board is bad. I mean, look at this catalytic capacitor. If this capacitor is blown, everything here is bad. Everything here is unusable. You have to replace this circuit board before you can use this battery again. So anyway, the best thing I can do right now is to charge each cell individually to its full voltage, which is 4.2 volts, and then we can go from there. Alright, so let me show you my setup here. It's a very simple setup. I got a couple of 18650 batteries. These are from a laptop battery, and they are fully charged. Okay, that's the important thing. You have to make sure they are fully charged. And I have two of these here. I have singles too, like this, but double is better. They are in parallel, so they are still 4.2 volts, but they'll give me double the amperage. And I'll show you. 4.12 volts, so they are fully charged. And what you have to do is very simple. Hook up the positive and the negative of this pack, right? And then, very important, I can't stress this enough. What you're gonna do is you're gonna use the positive terminal and hook up to the positive terminal of each individual batteries, of each individual cells here. So starting with this and this, you have to do individually. So we start with, I already started with this guy, so let's start with the second guy, this one right here. And let me do a before and after the charge. Okay, so 1.06 volts is before the charge. Okay, and you have to connect the positive end of this pack to the positive end of this cell right here, of every single cell. Okay, so positive to positive and negative to negative. If you don't, if you reverse the polarity, if you accidentally, I would say, connect the negative of this pack to the positive and positive to the negative, it's gonna be really bad. It's gonna be this full bar. You don't know what that means? Google is the best friend. I always have this sticker on my desk. I always blow something up, so if it's blown up, just put a sticker on it. Very simple, right? Anyway, so let's go. Alright, make sure I don't mess it up here. Positive and negative. Just hold it for, I would say, 10 seconds or so. Should be enough. This is just a boost. It doesn't have to be fully charged. What you're doing is just boosting it up so that to raise the voltage. That should be enough. And let's see what we got here. Make sure I don't short things out here. So before the charge is 1.06 volts. Now 3.13 volts. Only like 10-15 seconds. I did the bottom one, 2.66 volt. This one I only did like 10 seconds or less. This one, as you saw, I did it more than 10 seconds, probably 20 seconds. So I got more. So let's do the rest. Again, it's very important. You don't mess this up. It's something you don't mess up. Okay? You gotta do it right, like brain surgery. You do it wrong, you better wear a very good protective gear, because it's gonna be full bar. Spin up, and I'm gonna do the top one because it's the same polarity. That way I don't have to reverse the polarity. While doing this, I would highly advise you wearing protective gear. I have mine, protective gear here, so you should wear yours. And the last one we got that should be enough. I don't have a lot of patience right now. So let's see what we got. 2.66, 306, 305, 316, 307. Let me adjust the bottom one a little bit more because it's kind of low. Maybe 10 more seconds. Alright, hopefully that will do. Let me remove this before I sort things out. Alright, let's see what we got on this terminal here. Hopefully we get something. There you go. At least we got 8 volts. 8 volts, 8.5 volts. That's very promising. Now, let's do the parallel method again, because I did it before, it did not work. There we go. Let's do this again. Huh? Right, I'm ready for the parallel mode, rescue mode. So the way we do it is we have another good battery. It doesn't matter what brand it is. I got the volts here. This is Ryobi. Doesn't matter as long as it's the same voltage. So this is 20 volt. This is 18 volt. They're basically the same. So I hook up the negative to the negative terminal. You can see the black wire is a negative, the red wire is a positive, and you want to make sure that's the case, because you want to make sure you don't make a mistake here. Just use a voltmeter, try it. So if you don't see the negative sign here, then it's the correct polarity. So the positive is the red wire. Okay. So hook up the negative to negative and the positive to the positive. Okay. see what we got. $20.4. I'll let it charge for a little bit and I'll be back. Let's see what's gonna happen next. Alright, so after 10-15 minutes of charging, it does not take a charge. So I believe this circuit board, so I hook up all the wires together and it doesn't raise the voltage on this terminal itself. So I believe this circuit board is on the way. This circuit board is preventing charging it this way. Depends on what kind of battery, what kind of brand you have. Some other brands are easier to do it this way. This particular Ryobi brand does not let you do this. So what I'm going to do next is you're going to directly charge from the terminals. So I'm going to bypass the circuit board. So if you look here, these cells are connected in series, so it starts from here. So this is the positive terminal. As you can see, a red wire. This is a positive terminal. So positive, negative, positive, negative, positive, negative, positive. So it goes around. So the end is the negative. So between this terminal and this terminal right here, you can see easily the solder joint is very big. So that will indicate that's the main terminal. So the positive end is right here and the negative end is right here. Okay. So between this terminal and that terminal is 18 volts or 20 volts. And let's see what we got. So we got, as you can see here, we got I don't have good connection here. We got 15.2 volts in the battery pack itself. Okay. I don't have good connection here. 15.2 volts. But anyway, so the battery pack itself has 15 volts in total. When passing through this circuit board, it only has 8 volts left. So this circuit board is on the way and it's preventing me from charging in parallel mode with this terminal. So what I'm going to do next is I'm going to connect directly to the battery negative and the positive. Alright, so I just hooked it up and let's see what we got. So let's see, 1878, 79, 80 is rising, as you can see. 79, I'll let it charge for a few minutes. I'll be back. Alright, I've been charging this pack for like 10-15 minutes now, and let's see what we got. Come on. Got 18.63.64. So I believe we started it higher, at a higher voltage at 18.8. Now it's 18.63, which is dropping. As you can see, it is increasing right now from 6.3 to 6.4 now. As you can see. So what happened was when I hooked it up, it started 18.8 and then it dropped down to 18 volts, 18.0, and then it gradually increased now up to 18.63. So I believe what happened was this circuit board is on the way. It's trying to control something here, the charge here, even though it's not being charged by an actual charger. But you know, this is also why this battery failed, because most of the time this cell here, this cell can last hundreds of cycles, even thousands of cycles. But this board here does not. You see how much stuff, how much electronic components are in this board, including this capacitor here. But anyway, this board will mostly fail first before the cell fail. So that's the reason why this battery fails so fast, and it is trying to control too much, but at the same time it's not doing its job well, because if it does, then it shouldn't let this battery voltage go down to 0 when it's being hooked up to this device. I mean, you know, if it has some control, then it should cut the power when the voltage of battery is low enough, not down to 0. So this board is not doing its job, and it's just on the way. It does not do anything, it just make it fail faster. Maybe that's why they can make more money out of you, because now you have to buy a new battery. But anyway, so let's see what we got here. Again, 18.63. It's not increasing too much, but the difference is, let me show you this terminal. Now it's not 8 volts anymore, it's 18.5 volts now. And let me unplug everything here. I think that should be enough. By the way, there's no way I can plug this part in here, so I use a magnet, and it just stuck well with my alligator clip. Stuck like that. Very simple solution, eh? Now how do I get it out? Anyway, so it's unplugged, and before the charge, we got this terminal here at 8 volts, this here 15 volts, right? Let's see what's the difference right now. Come on. 18.35, 36 volts, and 18.3 volts. See the difference? Now it's different. And let me just, I think it's working now. So let's see. I'm going to put it back together, and I'm going to put it in the charger, and then we'll put I'm trying to run my tools to see if it works. Be right back. Alright, let's put it back together. Alright, let's see what we got. Beautiful. 18.3 volts, and I haven't even put it in a charger yet, or from this DeWalt battery. Let's see how much of a drop in voltage from my DeWalt battery. Wow, that's quite a drop. Before the charge, this battery was full. It was at 20.4 volts. Now it's only 18 volts. So a lot of energy is being transferred from this to this to make it from 0 to now 18.3. Oh, it's exactly the same voltage. Is it? No, it's not. 18.8. But anyway, so now we got some voltage. Let's try my tool, see if it works. And I haven't even put in my charger yet. Aha, it's powerful too, so that's pretty cool. Now I know that it works. Let's plug in my charger and see what's up. Alright, charger is plugged in. Red light, what does that mean? Power on. Okay. And blinking means charging. There you go. It works. So there you go. It's more complicated fixed, but it did fix instead of trashing this battery. So it works great. I'm gonna let it charge for a few minutes and then I'm gonna go back and try my tool again. Right, so I've been charging it for like 20 minutes now, and let's see what we got here. .3 volts. Now that's the difference. Now it's totally working. 20.3 volts. That's a big difference. Got my tools here, see what's up. Wow, that's strong. Let's see what we got here. 20.1. Wow. After a short burst, we've lost 0.2 volts. So it's very good. I would say it's back in business. So as you can see, this method is a little bit harder because it involves disassemble the battery. But other than that, it's the same. You actually probably can get away with charging individual cells. With this, you can just hook it up directly to the terminal, not to this, to the terminal inside the pack, right? To the actual terminal, not the one that goes through the circuit board, because the circuit board prevent that from happening. In this case, I mean, I have tried other brands such as Stanley Fat Max, Portal Cable, Black & Decker, and they are very simple. Just hook it up parallel. You don't have to remove anything, and it will be just fine after you charge it up. But not the same with this Ryobi thing. The circuit board here is too complicated, and it's prevent things from happening. It prevents you from doing a lot of things, and I don't see the benefit of it. It doesn't. It's people say it's there to prevent the battery voltage from dropping too low or damage the battery, right? Not true though. It does not prevent the battery from dropping to 0 volts when I use this radio. So what's the point of having a circuit board in this battery? The circuit board may prevent over discharge from using tools like this. You know, when you're using it, all of a sudden you lose power, you know the battery's dead. But with a tool like this, which discharges the battery slowly over time, it does not prevent the battery from being discharged, over discharged I mean. So what's the point of having the circuit board? So I think the circuit board is a conspiracy board, meaning it's there to make it die faster. And if it dies faster, you're gonna have to spend more money on a new battery, right? So if you buy more from Ryobi, it's good for Ryobi business. And that's the point of having a circuit board. That's why it's called a conspiracy circuit board. Now is the news. Ryobi stocks in the New York Stock Exchange has increased tenfold since the invention of the new so-called conspiracy circuit board inside the batteries, and blah 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 blah. Anyway, that's the end of my video, and make sure you buy Ryobi stocks, not Ryobi batteries, okay? This is a long way to fix, it's a harder way to fix, but it's the only way to fix with this kind of circuit board. So there you have it. I hope it helps, and if you like the video, thumbs up and subscribe. That will help me a lot. And until next time, thank you for watching.